Good morning to Dr. Susan. My name is Sharma Abdullah, 07 K18F1096. I will present about my industrial training, which is located at Jospek Sabah Tunjuan Berhad. Okay, first introduction. What is industrial training? Okay, industrial training is a must for students in certain programs at all level of higher education at the Institute of Higher Learning. Okay, the purpose of industrial training is to provide exposure for the students on practical engineering field. Okay, next, objective of industrial training. First, to expose students to the working environment in the industry. Okay, so objective of industrial training is basically as an early exposure for students before actually stepping into working environment in an industry, so student won't get shocked after stepping into working environment. Okay. The next one is a preparation or preview to working environment later in the future. It's like what I said before. It is to give student early exposure, so student won't get too shocked when stepping into working environment later. Okay. The next one is student will be able to familiarize themselves with receiving or advice and comply with directions giving employee. This is for students to get familiar with getting advice and directions and also complain from employee before actually stepping into working environment. Then next is to nurture a student leadership's ability and responsibility to perform or execute the given task. Okay. Next slide. Organization's background. Geospec was formed in June 1988 by a group of local engineers and earth science graduates to provide integrated geological, geophysical, and geotechnical investigations and testing service. There is three branch of Geospec, which is located in the main branch is in Kuching. The smaller branch is in Bintulu and also Sabah. For Sabah background, for Geospec Sabah background, it is officially open at 9 April 2019. For our laboratory work in Sabah, Geospec Sabah, it is include testing such as California bearing test ratio, compaction test, a tebak limit test, consolidations of soil test, bulk and dry density, particle size distribution, which is divided by two, hydrometer and dry sieving test. Okay, next slide. Works given during internship. Okay, the first slide is point load test. The first picture shows me picking the stone, and then the second picture is shown me measuring the stone. After we measure the stone, we have to cut the stone, and then I don't have the photos for the next step, but the next step we have to measure the stone again with vernier clipper, and then use the point load machine to like crack to break the stone or to put pressure on the stone until it breaks, and then we record how much load until the stone breaks. Okay, the next test is at the book limit test. The first photo shows me doing liquid limit test, and the second and third photos shows me doing plastic limit test. Okay, for the book limit test, the objective is to determine the liquid limit, plastic limit, and the plasticity index of a soil. For liquid limit test, we first take about 300 grams of soil and then place it on the glass plate. This is for natural soil only. For sandy soil, we put it in the oven for 24 hours first for oven dried, and then the next morning we crush it using mortar and then sieve it through 425 micrometer sieve, and then we took the soil sample that passed the 425 micrometers, and then the next step is to mix the sample using two palette knives, and then add more distilled water so that the first blow count is 40 and 45 blows of Casagrandes cup, and then after that we place the portions of mixed soil inside the Casagrandes cup, and then we use palette knife to level off the surface and to avoid entrapping any air, and then we blows the Casagrandes cup. If it's reached 40 to 45 blows, we took we took 10 gram of the soil sample and then put it inside the metal container and then place it into the oven. We repeat all the steps until we get 30 to 35 blows, 20 to 25 blows, and then lastly 10 to 15 blows. After getting all the blows, we place the remaining soil sample on top of a paper, and then label the paper and then put it inside the oven for for about 15 minutes and then took it out for plastic limit test. After taking out the soil from oven, we clean the soil sample from any pieces of paper, and then we mix the using a hand. We make the soil sample into a bowl and then divide the soil sample into two portions. Since we have to make two samples of plastic limit test, we use two portion of it, one portion for one metal container and one portion for one metal container. After divide the portion, we took small portion of the soil, then start rolling the soil until it cracked. We stop rolling after the soil. Stop rolling after the soil become 3 millimeters, and then we place it inside the metal container and then put it inside the oven for 24 hours. Then the next slide is particle size distribution. For this one, it is divided into two methods, which is hydrometer method and dry sieving method. For hydrometer method, I will explain the procedure using the photos that I put inside this slide. Which is the first one. After taking the moisture content of the soil, we didn't throw away the the oven dried moisture content sample. Instead, we took it and put it inside the plastic, the labeled plastic, and then we crush it using a mortar and then put it back inside the plastic, and then we mix it with dispersing agent until all the soil dispersed, and then we leave it for 24 hours. The next morning we mix the soil sample by shaking the cylinder. It's like the photos that I shown inside the slide, and then took the hydrometer reading. The particle size distribution objective is to determine the particle sizes of fine grained soil. And then for dry sieving method, after we wash the soil from the hydrometer method, the soil that retain on top of 150 micrometer sieve are taken, put it into a metal container and sieve. Correction, the sieve size is 63 micrometer. We actually manually sieve the soil so that the result will be more accurate. Then for moisture content test, this is the most easiest test, which is after the sample arrive from site, the first test we have to do is moisture content test. The objective of moisture content test is to determine the moisture content of soil sample. The first photo here is me mixing the soil sample so that the soil get mixed together with rocks. Then we wait the clean and dry container to get the containers mixed, and then put the soil sample inside the metal containers, and then we wait it to take the mass of soil sample plus container, and then we put it inside the oven for 24 hours to get the oven dried sample. And after that we wait the oven dried sample again and to get the moisture content. Okay, the next slide is field density test. Since field density test is done inside, we just do the sample preparations inside the laboratory. The first photos shows me washing the sand. We collect the sand from the nearby beach, and then we wash it until all the bubbles and all the dirt, bendasing such as leaves and branch, clear from the sand. And then after that we leave the basin full of water for like 1 day before throw the water away and sun dried the sample. After sun dried the sample until most of the water gone, we put it inside the oven to oven dry the sample. After oven dry the sample, we sieve it using 150 millimeter sieve and took the sample that retain on top of 150 millimeter sieve. Okay, finding and suggestions. For finding, I find that during the undergoing of industrial training, I've gotten many new experience and knowledge, and then the industrial training has given me the opportunity to feel the real atmosphere at work. And then I also find out that good communication and cooperation are important and can be seen while undergoing this exercise, as well as in helping and performing the work to work smoothly. And then I also found out that safety is very important during and after work for certain laboratory tests that involve heavy stuff and dangerous working environment. It is very emphasis at Geospec Scenario Berhad so the accident can be reduced. My suggestion is the company or firm should focus on student issue during the industrial training sessions as students are still new in the pre-employment nature, guidance from the firm observations are indispensable. Then company and firms should play an important roles in providing students with guidance on what's appropriate with the course learned by the student. And the company should also avoid giving different direction to student. This comes from my experience of working at Geospec near Berhad. There is time when the employer staff give different direction to student and the other staff give different directions to student, resulting a mistake of work during internship. So I think the company should avoid giving different directions to student. Okay, the next suggestion is the polytechnic should always keep in touch with the organizations or firm to keep up with the current development of students undergoing industrial training. And then the next suggestion is students should be more competent and timelier in doing the task given. So the company gives the trust to do something. Students should also be sensitive to such situations that occur during industrial training. I think students should be more sensitive and then more alert in what direction the staff gives so these situations can be avoided. Okay, for the conclusion, industrial trainings really benefit me as a student, and after undergoing 20 weeks of industrial training at Geospec Netherlands, I have gained a lot of knowledge and experience that I haven't learned and or experienced in polytechnic before. So the exposure of these industrial trainings really help a student about the working and technical aspect. Lastly, the conclusion is student involvement in industrial training like this can improve and further strengthen the student and identity in undergoing training in technical field. Thank you.